Last year, a device was assembled that used a radar module to detect a person and control an LED strip, illuminating only the necessary areas. Now it's time to update LightTrack. Similar systems on the market cost anywhere from $150 to $500, but they don't support truly dynamic lighting. Usually the LEDs just switch on when motion is detected. Another issue is that light under the steps can be too bright, since it's often at eye level or higher. Installing such systems usually requires dismantling the staircase, placing strips under each step, installing sensors, and hiding the wiring, which can run from $300 to $1,000. This new device solves most of those shortcomings: convenient phone control, color changes, length of the light beam, runtime settings, minimal power consumption, and much lower component cost. Here's what was done to address various challenges and how they were solved. LightTrack was developed last year and worked well, but lacked adjustable settings. A schedule feature, color selection, brightness control, and other parameters were added. That required Wi-Fi. A compact module was found, but it needed 3.3 volts while the Arduino ran on 5 volts, so a voltage converter and multiple connectors were necessary. This setup turned out to be very unreliable. One loose wire would make everything stop working. On top of that, it wouldn't fit inside the enclosure, and increasing the device size wasn't an option. Another approach was needed. The solution was to switch to an ESP32 Super Mini microprocessor. It's cheaper than an Arduino, plus a separate Wi-Fi module. It's more compact, reducing wiring and increasing reliability. It has built-in 5th-generation Wi-Fi. It runs at 240 MHz instead of Arduino's 16 MHz. It has 4 MB of memory, enabling a full web interface for phone-based control. Porting the code from Arduino to ESP32 was a challenging process. Much of it had to be rewritten, but the result was well worth it. Everything became very compact, and a new enclosure was designed, allowing the lower cover to be mounted on a wall. A thermal imaging camera was used first to check the microprocessor temperature and ensure it wasn't overheating, which could cause malfunctions or even permanent damage. Everything checked out fine. Then, testing began. Initially it worked as intended, but after about 3 hours, the light moved along the strip more sluggishly, and after 12 hours, it switched on with a noticeable delay and moved even more slowly. The internal log showed the device was entering sleep mode after a long idle period, requiring time to wake up. Disabling sleep mode was tried first, but the device still went to sleep. The radar module had its own sleep feature that couldn't be turned off, so a signal was sent every 15 minutes to keep it active. However, the problem persisted. After a few hours, the strip's motion slowed dramatically again. The log revealed that a huge data array was accumulating in memory, heavily loading the microprocessor. A memory clear function was added to the code, but it made no difference. The ultimate solution was a soft system reboot every 30 minutes, which includes a full data purge. The reboot is quick and barely noticeable, and it resolved the performance drop. Next came the real-world installation on a staircase. There isn't a personal house available yet, but a friend liked the device and wanted it for a home staircase. Installation is very straightforward. Attach the radar module to a wall and run a cable to where the LED strip is mounted. Placing the module so it detects a person well before reaching the stairs is ideal, so it was installed in a wall corner. The LED strip went under the handrail to prevent glare. An extension cable was used between the module and the strip because the distance was considerable, and using the strip itself as wire would be unwise. The protective backing was removed, the LED strip was carefully attached to the handrail, and after testing, the wiring was hidden in a cable channel on the wall. During testing, an old issue reappeared. The moving light was slow and barely kept pace. More frequent reboots seemed necessary. By this point, the device felt like a series of workarounds rather than a smooth solution. It was time for a more thorough fix. The software was essentially reworked and moved to the FreeRTOS operating system, which splits functions more efficiently and helps manage processor load. This solved all previous issues, and now the moving light operates at the desired speed. Here are the main controller settings. Select a base color for the lighting. Adjust brightness for the moving light. Set brightness for the stationary part of the effect. Configure the length of the light beam that follows a person. Option to detect movement direction and shift the entire light beam forward. Both modes can operate together. Calibrate the center offset. If the radar and LED strip are placed apart, center offset compensates for that difference. You can set the interval during which the beam remains lit, even if no movement is detected. This parameter can be adjusted from 1 to 60 seconds. Schedule the device's active time. A time interval can be set for when the device should operate. Power consumption was tested and found to be under 2 watts in standard settings, which is very low for a system like this. Anyone interested can order a device on Kickstarter. A new company was formed, and if the necessary funds are raised, components can be purchased in bulk, allowing a final price of $80, including shipping, for early backers. It's also possible to assemble the device independently by purchasing the required components, about $45, and programming the microcontroller. If a 3D printer is available for the enclosure, that's all it takes. Otherwise, printing services cost around $15 plus shipping, totaling about $60. All relevant links will be shared in the video description. Thanks to a subscriber named Robbie, a new idea surfaced. Hang an aluminum profile with an LED strip from the ceiling and position the radar module on a wall, creating smart lighting for a hallway. Everything is ready. Hopefully, this video will inspire others to create their own smart lighting systems. Thanks for watching.